Okay, step 2. Well, alpha level that I mentioned we're working with is 0.05. The book doesn't say that, so I had to use one, so I decided 0.05. We know it's a two-tailed test, and our degrees of freedom is 4. Little n is 6, right? There were 6 pairs of scores, 6 people in the study. So again, we go to our critical R table. The second row is for two-tailed. We're doing 0.05, so we want this second column here, and we want to go down to 4 degrees of freedom. And in doing so, we can see that our critical R is plus or minus 0.811. So just like our olden days, plus or minus 2 tails, we're looking both directions. Maybe it'll be a positive relationship, maybe it'll be negative. We already know from the scattergram that it's negative. But here are our critical regions, plus 0.811, minus 0.811. So the next thing to do here is step 3. And since it's just the 4 calculations, I can make it fit in the same video clip here. So the first thing we need is our sums of squares for the x variable, which again is the summation of squared x's minus the summation of x squared over n. So we've already got everything we need here from the prep stage. We know that the summation of squared x values was 22. We know that the summation of x was 8. And we know the number of people in the sample, the number of pairs of scores is 6. So again, square your 8 first, then divide by 6, then subtract it out of 22, and we end up with a decimal. So we're going to have to write a rounded value but compute with full values. What we end up with here is 11.33, which is really 11.33333333. Next up, looking for our variability in just the y variable. And again, all we've got to do is look on the prep work and plug in what we got there. The summation of squared y's was 53. Just the straight up summation of y's was 15. So again, square your 15, divide that by 6, subtract that out of your 53. And you get 15.50. Don't forget your last 0 in the hundreds place there. Sums of products. Now our measurement of covariance, or covariability. How are these things varying together? So we know we need the summation of x times y minus the summation of x times the summation of y over n. So again, we've got all these values. Our sum of products, our summation of x times y's was 10. Summation of x was 8. Summation of y was 15. And again, there's still six people, 6 pairs of scores in the data. So 8 times 15 first, then divide by 6, then subtract that out of your 10, and you get a sums of products of negative 10. So again, sums of squares have to be positive, but sums of products could be positive or negative. We should have expected a negative value there because we already know from the scatter plot in the prep stage that we've got a negative direction. So something had to sure not to be negative, and since that's the only thing that can amongst these 3. And then lastly, the R. Covariance on the top, independence on the bottom. So our sums of products is negative 10. Our sums of squares for variable x was 11.33333333. Our sums of squares for variable y was 15.50. For a lot of students, this is the trickiest one of them all. So make sure you multiply here first, 15.50 times 11.333333. Square root that, and then divide that into -10. What you're going to get, of course, is another decimal that has to be rounded. The answer you should be seeing in your calculator is 0.0569 blah, blah, blah. So when we round that to our hundredths place for reporting, we're going to see that our answer is 0.06. So even smaller than what I guessed from our scatter plot. I said probably in the 20s, maybe as high as the 30s. It was lower than that. I mean, that's about as close to an absolute zero as you're going to get. But that's all there is to the math part of this. Our two sums of squares, our sums of products, and then our R statistic, our R correlation coefficient. Oops, missed a little bracket there. So that is it for step 3, which means the only thing left to do is step 4. So we know from step 2, our critical value was 8.11. We know from step 3, our R statistic or our correlation value was 0.06. Oh, actually it's negative. Put that on the other side. Keep on the right 60 because 0.6 is so small. So where did we land? Obviously not in the tails. We're almost dead center in the body. So our decision is fail to reject. So our decision is fail to reject the null hypothesis. We have an R equal to negative 0.06, semicolon, N equals 6, semicolon, P greater than 0.05. So for this chapter, the hypothesis test is certainly the shortest part of it, if you will. We've got quite a bit of associative vocabulary we need to go through now. We've got at least 3 more sections of info, maybe more than that. So we will obviously continue that when we continue with the next video.